In today's Spotlight in Science, you will see two 5th grade classrooms and their challenge of adding a balloon motor to their jet toy for our force and motion unit. Students have only received direct instruction on how to build their chassis. Chassis have been tested to ensure that they travel in a straight line. Students in Group 1 were not given any direct instruction on how to add the balloon motor to the chassis. They were simply told that the challenge was to mount the balloon motor to their chassis. The materials that they had available to them were index cards, drinking straws, and masking tape. They were also reminded that their group needed to come up with a plan and that all must agree on the plan before they added the balloon motor.
I was going to put it like this, because this way the air would get pushed out this way, making it the front and the back.
Because if it wasn't here, the air would be pushing out to here, and it would probably be blocked, and it would go like.
But make it more realistic.
Yeah.
So you want to mount this underneath your car?
Yeah. But if we can't do that, then we'll go like maybe.
Okay. Tell me why you think that would work.
Because the air's going out that way.
The air would be going under the car. Well, it would work because the air would be still pushing it out.
Do you have room to tape that to the bottom side of your chassis?
No.
So is that going to work?
No.
So then the top.
So we have to go on the top.
And which way is the front?
Right here. You're going to put it.
This is the front?
Yep.
Yeah, and we're going to put this right here.
So we put this like right here?
Yeah.
It'll blow up like this.
How are you going to attach it?
Tape that. Maybe something like that.
Is that going to be stable enough?
Huh?
Is that going to be stable enough?
No.
How are you going to make it stable?
I think I have an idea.
Guys, we can go like this.
Only if we could we like cut a little piece open and then like set it in here like tentatively and then tape it down.
We could even put it in here. We also put it in here and it'll still go if we put it in here.
So what Benya's saying is stop. Benya's saying cut a little piece of this out so that this rests in there and then tape it in there?
Yeah.
Why is cutting that little piece out going to be helpful, Benya?
This could probably stay in here, and then when we tape it down, this could
Have a place to rest.
Not only to rest. As you can see, all members of the group were working together to solve the problem. They listened carefully to each other and were definitely drawing on some prior knowledge to solve their problem. The knowledge, though, did not come from school. Another straw underneath it?
Yeah.
Okay, I want to know why you guys decided the straw thing.
Oh, they did. I didn't know.
So we could keep it stable. We don't
Keep it stable?
Yeah, and like
Okay.
down.
So let's try. I would say try it.
So make the whole.
You know, there's the worst we can do is we have a new chassis, right?
Yeah.
Each of the teams showed an incredible amount of thought. Some teams wanted me to make their decisions for them, and as much as I wanted to tell them how, I simply said, let's try it, or what does your group think?
Yeah. Because maybe it was in the wrong spot.
What's in the wrong spot?
The balloon.
Okay, why don't you... Students in Group 2 did receive direct instruction on adding the balloon motor. They were shown 3 different ways that they could mount the motor. Students were also told that they did not have to use one of these 3 ways, that their group could work together to come up with their own plan. They had access to the same materials as Group 1, masking tape, index cards, and drinking straws. And they were reminded that they needed to work together as a team. So tell me what you're doing here then.
We're gonna like punch a bunch of holes until it can fit through.
Students in Group 2 primarily used one of the 3 methods. There was one group that did modify the vertical support and platform methods, creating a very sturdy support for their balloon motor. The way that Group 2 mounted their balloon motors was very similar to the three pictures that they were shown. All of the groups were successful in getting their cars to go a few meters and in a straight line. The process of adding the balloon motor and testing was not problem-free. Teams had to work together to overcome axles falling off, crooked axles, as well as balloons rubbing on the floor. In the end, both groups were successful in the completion of the goal, mounting the balloon motor and having it go in a straight line for a few meters. Group 1 received no direct instruction in the process and had to draw on their own knowledge to solve the problem. This learning activity would be best classified as a social constructivism. Students had to collaborate and rely on personal knowledge to complete the challenge. Group 2 was, however, given 3 specific ways to add the motor. They processed the information given to them, and their solutions didn't alter much from the pictures. The most interesting thing to me was not that both groups completed virtually identical cars, but instead it was the conversations that the students had during the process. Students in Group 1 had to first share ideas in order to develop a game plan. They had to listen to their team members carefully to make sure they understood each idea. They also had to weigh the merits of each idea and choose the one they thought was best. During this process, they had to rely heavily on their team's explanation, their own questioning, as well as personal knowledge, therefore strengthening their own understanding. Group 2 simply chose one of the 3 methods. There was little, if any, variation from the method shown. While students in this group did discuss which method they thought was best, they didn't think outside the box and try something new. Even though they were told that these might not be the best methods, the students' creativity and problem-solving skills were not seen during this process. While I think modeling is crucial to student understanding, I also think that it's important to let the students create on their own. Allowing their own creativity, problem-solving skills, as well as personal knowledge to shine through allows for them to make some amazing strides in their own understanding and learning.